Good afternoon, everyone. Thanks for joining us today for today's webinar. Today's topic is about a precision part that often gets less than precision attention, the tapered roller bearing. To tell us more about how to properly service and care for this important component is Timken Senior Product Analyst Rick Dauman. Before I turn it over to Rick, though, just a couple of quick notes. You can submit questions anytime during the presentation using the box at the bottom left of your presentation screen. We will, however, wait until the end of the presentation to address those for you. So without further ado, let me welcome Rick Dauman. Rick, it's all yours.
Hey, thank you, Pete, and thanks for joining us, everyone. Today we're going to cover tapered roller bearing service. And first, let me start off by talking about Timken and where the tapered roller bearing came from. In 1895, Henry Timken designed a tapered roller bearing to reduce friction. And what he noticed was that heavily loaded freight wagons had difficulty making sharp turns. After that, in 1899, he established the Timken Roller Bearing Company. And in 1902, he moved it to Canton, Ohio, and that was due to the location of the steel supply and his customers in the automotive and wagon industry. All right, let's review the components of the tapered roller bearing. First off, we have the cup, or the outer ring, which is sometimes referred to as a race. Next would be the cone, or the inner ring, which when combined with the other components make up what most people refer to as the bearing. The roller is used to minimize friction between the rotating and stationary members, while the cage spaces the rollers. It actually carries no load in operation, but it's used to contain the rollers during assembly and disassembly. Now, every once in a while I get a question, what about a polymer cage? Why would you put a polymer cage on there? Well, the advantages of a polymer cage is you can actually move it out on the roller or closer to the cup. The polymer will not score or mark the material or the cup raceway just because it is plastic. The advantage of pushing it out there, though, is sometimes you can actually move the rollers close enough together that you can add an extra roller to the assembly, which actually increases the load. So the capacity of the same component is increased. Now, not all cone assemblies with a polymer cage are more capacity than a standard cage, but it is a possibility in the design.
Okay, so if you're one of those guys like me that always looks at things with a raised eyebrow, sees a polymer cage, that certainly does not indicate a bearing of a lower quality.
Oh, absolutely not. I mean, the design or the thought behind it is the polymer, like I said, we can put it up higher on the roller, which allows it to be closer to the cup, but we don't have to worry about the cage actually contacting the cup or doing any damage to the cup. So it is definitely not a sign of a cheaper or more inferior product. It is actually a better product. Okay, moving on. Now, since we know the components, what I want to show you here is I'm going to highlight that the reasons that we should change the cup and cone together. The cup the bearing assembly is really intricate, and the design is within the millions. Since the bearing designs use special profiles on the cup, cone, and rollers, it is recommended that you use the inner and outer or cup and cone from the same manufacturer. The profiles may be different from different manufacturers, and most likely are. Another thing to point out is if you look at the orange wear pattern versus the aqua blue wear pattern, what we're trying to show you there is that if you don't replace both components, the cup and the cone at the same time, you could actually reduce the life of the assembly or the bearings that you just put in there, simply because the contact patch or the riding surface will be in a different location, which can increase the stresses and reduce the life of the bearing. Now, the same manufacturers, we know that our profiles on our cup work with our profiles on our rollers, and so consequently that's why we stress that you should use the cup and the cone from the same manufacturer. Okay, now on to some bearing installation and handling stuff. what we're going to talk about today is the importance of cleanliness, the importance of proper handling in the use of the proper installation tools, and then we're going to highlight a little bit about lubrication here and why that's so important. All right, what you see in the photos here are the effects of contamination and what it can do to a bearing. You notice we call this bruising, and it might be hard to see in the photos, but these are actually little indentations in the raceway. This is due to debris from either other fatigue parts or leaky seal or contaminated lubricant. Okay, this debris can also come from, say, in an axle housing where the gears are creating debris and it's flowing through the oil. If that gets pumped through the bearing, it will create bruising similar to this or marking similar to this.
I guess now this is, excuse me, Rick, that's almost like if you're putting an engine together. I mean, you want to be very careful that there's no dirt or debris getting into those plain bearings while you're assembling the engine, the crank, the rod, and the cylinders, anywhere else. But most of us, I guess, don't think of the same thing when we think of the tapered bearings doing a brake job. But it really is that critical of a bearing, isn't it?
Oh, absolutely. And like we were talking about before here, the profiles are the tolerance on the profiles. The raceways, you think they look flat, but they're not. They're actually crowned. They have opposing crowns that ride together, and those tolerances are within, I mean, they're down to the millionths of an inch. So it is very critical that we don't put debris in there, and it is the same as assembling a plain bearing in an engine. I mean, the cleanliness is next to godliness. So, all right, the next example of contamination is in the form of moisture. If we look at the photo in the upper left there, what you'll notice is that the dark lines there are actually etching or rusting with pitting and corrosion from moisture and water exposure. And you think, well, how in the world would you get, why would you put water on your bearing? Well, you don't necessarily put water on your bearing, but when you clean your bearing before assembly, if you don't lubricate it, or if it sits in, say, your cold garage and the temperature goes up and down, you know how steel sweats out in our garages. What can happen is you'll notice that the moisture is equally spaced on the cup raceway there. Well, that's an indication that the moisture formed between the roller and race contact area. This little bit of condensation, I mean, it can happen in a matter of hours. This little bit of condensation, if you operate the bearing will look like the picture in the lower right there. This is called line spalling or roller space spalling. And this is what happens after the bearing was operated, after it was etched from corrosion. Now, this can also happen to a bearing that, like a boat trailer bearing, where you have a leaky seal and you're operating the bearing, it actually sucks water in through the seal and gets on the rolling elements. Well, when we let them sit all winter, then consequently this etching can occur also.
Yeah, I think that was another good point that we kind of talked about when we were putting this together for the folks, that a lot of us do that kind of service for our customers, and it really makes sense to service these bearings before storage, rather than waiting until after you pull it out of storage.
Absolutely. You can actually prevent replacement if you just tear them apart, clean them up, make sure you pre-lube them again and put them back together. That way you get all the moisture out of there prior to letting them sit for long periods of time. That's a good point. All right, now let's move on to handling. Okay, now first thing is, do not use hardened drifts or center punches. They can create, when the installation tool has the same hardness or harder than the bearing component that it's being pressed against, you can actually create damage. You will damage us. There's an example of it there in the photo. The reason that we don't like brass bars, this will actually peel or create metal flakes that will get into the bearing, and you think of brass as being soft, and yes it is, but if it's repeatedly run through the bearing assembly, it will create spalling or bruising and denting. We recommend...
Isn't it also possible, I'm sorry, Rick. Isn't it also possible to deform the contact surfaces using like a pinpoint tool to have a direct, more direct pressure?
Oh, absolutely. As you can see in that photo there, it shows you that someone used a hardened drift, and when the metal was displaced on the face there, it actually protruded into the raceway. Well, that protrusion creates a high spot. That high spot, whenever you roll over it with the rollers, creates extremely high stress, which fatigue the metal and cause the spalling. Okay. Now, another issue that we've seen as far as handling goes is, I've been in the shop many years, and every once in a while you drop a bearing. It's going to happen. We don't like it to happen. The first thing you have to do is check for cage damage. I recommend, if you can, just don't even use it. Sometimes you can't see the damage, but if you must, you can see the cage deformation in the photo on the upper right there. That is extreme. A lot of times it won't be that pronounced. So one of my tricks is I actually take the cone assembly and place it into a cup, and that gives me a point of reference, a roundness reference, so I can actually eyeball the cage and see if there's any sharp or any deformation that I didn't notice without the cup being on there. At the same time, you can flip it over and look at the front face, because the front face is just as susceptible to damage as the back face here. Another possibility, when installing bearings, especially on like pinions where you have to press them on and it takes quite a bit of force, if you contact the front face of the cage or the part that sticks out over the small end, if you compress that, you can actually spread that cage. And by spreading, I mean you can open it up. This can do a couple of different things. First of all, it can cause binding during operation. It can also allow it to hit the cup or the outer race during operation. Now, this photo on the left here is an example of skewing, and what has happened is that cage was distorted, and it caused a dragging, or the rollers were not allowed to roll true around the raceway there. And what you see is results of skidding and damage to the bearing assembly.
Now, I was concerned about cage damage just limited to the steel cages, Rick?
Oh, absolutely not. If you drop a polymer cage, most likely what's going to happen with a polymer cage is that it will break. You'll notice that if you pull or move the cage around. Polymer cages tend to run, they feel like they're tighter. They don't have near as much cage shake as a steel cage because they can contact the rollers. So you don't need the clearance there that you do on a steel cage. But you can use a broken polymer cage as long as the assembly stays together during installation. Okay? All right, next I want to point out the proper cup driver. If you'll notice that the tool actually pilots on the small ID of the cup, while the flange is applying force to the front face of the cup. So you can just imagine there that when you're hammering, or actually I prefer to press them in just because of the equal force distribution, it's actually only pressing on the front face of the cup. It's not contacting the raceway anywhere. Again, this is just to prevent damage to the raceway as indentations, or as in the photos below there. All right, now let's move on to lubrication. All right, the life of a Timken bearing depends to a great extent on the proper lubrication of the bearing. Lubricants aid in carrying away heat, protecting bearing surfaces from corrosion, and reducing friction. Statistics show that nearly 50% of all bearing damage can be attributed to inadequate lubrication. Although a very broad term, inadequate lubrication can be classified into 8 basic categories. All right, first off, we have overfilling. Overfilling can cause excessive heat and pressure due to churning. It's almost like you're causing the heat can't get away because there's too much lubricant in the cavity. Underfilling, that will cause excessive heat also, but it's due to the lack of lubrication, not because of too much lubrication. All right, incorrect grease. This is referring to the type of grease that is used in the application may not be correct for the application to be able to handle the loads in the conditions, the service conditions. And we have a mixing of greases. This is mainly referencing to old and new grease, but it also can come into play if you're adding grease to an existing assembly and you add a different grease. The greases can react and the additives and they will not perform up to standards. All right, incorrect lubrication intervals. Of course, this is referring to improper maintenance. Worn out grease. Grease is basically an oil suspended in a wax, so it is just like leaving your oil in your car too long. Okay, there is an actual shelf life for the grease or a usage of the grease, so it should be replaced. Water contamination. This goes back to our boat trailer bearings or just not handling the grease correctly where it can actually absorb moisture. Then of course debris contamination. We don't like dirt in our grease, and this will lead to back to the first pictures that we showed about the damage to the raceways from dirt or contamination.
Yeah, Rick, I want to kind of stress this point because I know that I admit I've been guilty of it. You're doing a front brake job. You have the bearings out to remove the rotor. You're setting the bearing up on the rack, and then when you come back, you're in a hurry. You throw it back in there again. Let's go over that a little more because again, this is a precision component. If we want to make a difference between doing it so-so or doing a truly professional job for our customers, how should we properly, clean the bearing? What are some other things that we can look at, while we're have the bearing in our hand? And then what's the proper way to get that lube back in there?
Oh, sure. Cleaning the bearing, we recommend a kerosene-based solvent or normally whatever you keep in your clean tanks. You do wash the bearing out as thoroughly as you can. Get all the old lubricant out of there to include the contaminants. You can blow dry, and I do recommend you blow dry the bearing, but I want to caution you, you do not spin a bearing with air. Plastic cages or steel cages, it doesn't matter. Do not spin them. First of all, it's not good for the bearing to spin, especially when it's dry. And second of all, the cage can't expand and expel a roller, which is, of course, is dangerous. As far as how to properly lubricate a bearing, there are tools out there called bearing packers. That's the easy way to do it. The way I prefer to do it is it's called hand packing. It's where you put a glob of grease in your hand, and then you hold the large end of the cone and just start scraping the grease off. And what it does is it actually works the lubricant or the grease up through the rollers and will come out the small end of the cage.
Now that's really neat, Rick. That's a really neat comment there, Rick, because I know the way I grew up on it, and that was a long time ago. So sometimes the old ways are still the best ways, huh? Oh,
absolutely. I'm old school too. I like I don't mind getting my hands dirty once in a while.
Yeah. Real question then, what about some of the synthetic greases that are available now?
Can you use them? Absolutely. I have no problem with synthetic grease. Are they better? Well, because of the way synthetics are manufactured, I'm not a lubrication expert, but they're more. What they start with is because they're handmade, they're actually more tighter control. So yes, I believe in synthetic lubricants of all kinds.
Cool. And then when you're putting the lubrication back up, I mean, we've got the bearing packed properly, cleaned properly. We've checked it for obvious signs of visible damage. Now again, I'm just kind of focused more on the bearing work, like at a brake job, because it's the rear ends are going to be lubed by the rear end grease and oil air. So what about the lubricating the cup and cone and in the hub itself before you reassemble? Should you put a layer on both? Should you put any into the hub assembly, or how should that be done?
Absolutely. When you're done packing the cone assembly, then I take and smear some on the OD also. The cups should already be installed into a cleaned hub. You got to get all the old grease out of there. We don't want to contaminate or mix lubricants, and you want to get all the contamination out of there that you can. And then you lightly coat or fill the cavity between the bearings should be 1/3 to no more than 1/2 of the available space in there. Now you got to remember the spindle is going through there, so a rule of thumb is I put no more lubricant or grease in the hub assembly than the smallest diameter of the cups. So what you'll notice when the cups are pressed in there, that cavity, that space between those two cups, I don't prefer any more grease than just covering that surface in there. And what you're trying to do is prevent contamination due to corrosion. So if you have any exposed surfaces in there, it's better off just to cover them with the lubricant to keep them from corroding.
Yeah, and I think you mentioned earlier that if you take and pack all that dead space with grease, that's actually just as bad as not having enough.
Absolutely. You can create, it builds up heat. Just their lubricant and these materials all expand and contract with temperature changes. So consequently, by packing it full of grease, you're taking the airspace away, or the allowable room for it to expand and contract. And don't be surprised to see grease purging from the seal. A grease seal is made to purge or to let off air pressure or pressure build up in the system, and if there's too much grease in there, it's just going to squirt the grease out.
Oh, good. Thank you.
Okay. Now another thing I want to point out, you should also, the hubcap, I always put a light coating on the hubcap just to prevent corrosion. All right, it doesn't really do anything as far as lubricating the bearing, but it keeps the hubcap from rusting inside of there and getting contamination in the grease.
That is a good point, though, Rick. I'd like to ask your opinion on that. I mean, sometimes the hubcap is deformed or damaged on removal, and that is keeping debris out, isn't it?
Absolutely. That is a seal. So the press, the fit of that hubcap into the end of the hub is important to the sealing of the bearing or the sealing of the whole assembly. So the way I think of it is having a little bit of grease come out of there, all it's doing is helping to seal that up.
Yeah, so if it's damaged, replace it when you do the work.
Yes, absolutely. All right. For disc and drum applications, we recommend NLGI GCLB certified NLGI number 2 lithium complex. Now we do have our own grease, but as long as your grease meets these specifications, you should be good to go.
Here's an interesting question for you, Rick, but I want to interject here. I'm sorry to interrupt you, but kind of meets right in with your specifications here. If the two different greases meet those same specifications, are they considered compatible, or you still think that one should be totally removed before the other one's replaced?
Well, I suggest that you totally remove it, but that's due more to the contamination that was previously there or possibly there. As far as will they mix, as far as I know, the rating will tell you that yes, they will mix, but there are additives in the grease just similar to oil that I can't swear that every brand will mix just because they meet these ratings. Okay,
yeah, that's on the safe side. Yeah, err on the safe side and stick with one or the other, but don't mix the two.
Absolutely. Okay. So for best results, ample space is essential in the housing like we talked about to allow room for excess grease to be thrown from the bearing and for heat dissipation. These bearings are like mini pumps. As they rotate, the grease is pumped from the small end to the large end, and so you need a little bit of room in there for the grease to move around. It's equally important to retain the grease around the bearing. Normally the housing should be 1/3 to no more than half full of grease like we talked about. Too much grease in the housing may cause excess churning of the grease and high temperatures. All right, now we're going to look at some examples of damage related to lube. Now I know I said earlier that most damage to a bearing can be related to lube, but and you'll see why here, what I'm referring to as we go along here. All right, this cone shows heat generation at the cone large rib and subsequent damage to the roller large end. Okay, this will be the first area of a bearing to show evidence of excessive heat due to the fact that the interface between the roller and the rib of the cone is the only surface of the bearing that has sliding contact. All right, so what I'm saying is if you look at those photos, you notice how it's darkened there. It's discolored on the roller large end and the rib face, which is where that roller rides against. And that's due to the heat buildup from the sliding contact. Now, this damage is labeled as inadequate lube, but that doesn't mean that it was dry or it didn't have any lubrication. it meant that the lube was not adequate to sustain the loads placed on the rib and roller contact area. This can be a result of excessive preload due to the improper adjustment, which caused the rollers to slide instead of rotating. Or it can just be that the lubricant was insufficient or didn't have the right additives to suspend or to sustain the load. All right, now we look at another example of inadequate lubrication, and this is damage to the raceway surface due to thin film lubricant. That means that either the lube was inadequate in either fill or type, or the bearing was overloaded, which would not allow sufficient amount of lubricant between the rollers and raceway. Now, just like the rib we just talked about, that it needs lubricant between the metal contact surfaces to keep them from having metal-to-metal contact. The raceway also needs lubricant between the roller and the raceways.
It'd be like using the wrong oil in the engine for the plain bearing.
Exactly the same. Okay, it has to meet the specs to sustain the loading that they're going to see.
Wow.
Okay, the overloading may be due to improper adjustment, or it may be excessive loads on the vehicle itself. Now, a couple common vehicles that I see that are frequently overloaded are like cement trucks or garbage trucks. They tend to abuse those the worst. Now, in this case, this peeling or microspalling due to thin film lubricant from high loads or low RPM or elevated temperatures, you will probably also notice that on a cone assembly that was with this mating condition, the bores will probably be shiny. Okay, and what that means is that the ID of that inner raceway or the bearing itself was probably turning on the shaft or on the spindle, and that's what polished the ID. All right, now let's get into the features of a tapered roller bearing and the adjustment process. All right, now we're going to talk about bearing adjustment. If you look at the cross section of the hub assembly, you see it's a 2TS or tapered single bearings, inner row and outer row, along with an adjusting nut to control and hold the setting. Think of it as two wedges facing each other, and as you tighten the adjusting nut, you are forcing the wedges together. If you tighten the bearings, driving them together, you're removing all of the clearance in the assembly. Once you remove all that clearance, this is called line-to-line or zero clearance. If you tighten the adjusting nut past this zero clearance or induce a preload, what that is doing is you're inducing a load into the bearings before the weight of the vehicle is even added. So we call it preload, or it's loading the bearings prior to operation. Okay? When you loosen the adjusting nut, you're removing a load and allowing clearance in the assembly. This is called end play, which means the hub can actually be moved axially or in and out. This clearance is measurable and is what we ask you to check. Okay, this is the basis of our adjustment. All right, wheel bearing adjustment. The purpose is to achieve a verifiable, measurable wheel bearing end play of 1 to 5 thousandths is my recommendation. Why? Precise bearing settings increases wheel and component life and prevents premature damage. The procedure that we're going to talk about is a torque back-off and verification sequence. Okay? All right, step 1. Using a torque wrench, you need to tighten the adjusting nut to 50 foot-pounds while turning the rotor. Now, this is for automotive-size wheel bearings. All right, and then you ask, why do you turn the rotor? Is that the... If you look at the photo in the bottom there, you'll see the small rib reference there, and you'll see a dotted line indicating the unseated roller. A bearing not loaded, the rollers will tend to fall down to the smallest diameter due to gravity. As you put torque on or adjust the assembly and start tightening that or driving that wedge together, you need to rotate those rollers to allow the rollers to walk up the rib or walk up the raceway and contact the large rib. This is the way you'll get the most accurate setting, or the only way to get your accurate setting. All right, the 50 foot-pounds is not to make sure the bearings are pressed all the way in. It's not going to, if your cups are not seated correctly, this 50 foot-pounds will not seat them, and we don't recommend that you seat them that way. All right, what you're actually doing is making sure the seal is seated and you're getting a good point of reference. And I prefer if you back it off half to full turn, and then go ahead, while you're spinning the hub, torque it back up to about 10 foot-pounds is a good starting point while you're spinning the rotor. All right, then you want to back off the adjusting nut 1/6 to 1/4 of a turn, and that's all dependent on how you lining up the lock nut, whether you have a tanged washer or whether the nut itself is tanged and you have to line it up.
I think that's a good point that I want to kind of reinforce there, Rick. I mean, once you have it set, you're not going to tighten it further to get that little lock tab to fit. You're going to back it off to get that lock tab to fit.
Absolutely. Okay, so place the bottle cap type stamping over the nut and insert the cotter pin. Or if you have a castellated nut, you go ahead and locate or line up the castellations and insert the cotter pin. Now that leads us to our last step. Okay, and I know people say, well, I know this is a lot of work, but to verify your end play, what you should do is use a dial indicator to measure the actual end play or the movement of the hub. All right, so mount the indicator base, and I'm using a magnetic indicator base in this photo, to the rotor, to the center of the hub rotor as close as possible. You know you're not going to be able to get it right on the center, but put the indicator tip against the end of the spindle. So now you have the base on the hub and the tip on the end of the spindle. Okay, I want you to grab the rotor at 3 o'clock and 9 o'clock. Push the rotor in while oscillating and read the dial indicator. Pull the rotor out or hub out while oscillating and read the dial indicator again.
Can you clarify what you mean by the oscillating there, Rick?
Yeah, oscillating would be like rotating back and forth. Okay, you're not going to be able to spin it because you'll knock the indicator off most likely. But what you can do is, all you're doing is in a couple slide or two earlier, we were talking about making sure the rollers were seated all the way against the large rib. And that's in essence what you're doing. As you push and oscillate, you're putting force on the inner bearing, and you're oscillating or rotating back and forth to make sure that the rollers are seated all the way against the large rib. Then when you pull on the assembly and oscillate, you're actually rotating or putting force on the outer cone or the outer bearing assembly, and you want to rotate to make sure you get the rollers seated on the rib. That's going to measure your clearance, because you got to remember now, you're measuring the clearance between the inner and the outer bearing. It's a combined total. Okay, so when we say thousandths of clearance, that's only a half thousandth of clearance on the inner bearing and a half thousandths clearance on the outer bearing.
Wow. You mean my old mechanics feel after 30 years in the field that's not good enough?
Well, you may get that good, but what I'd like you to do is check it. Just try this one time. Do your torque and back off procedure as you used to do, okay, and get your setting where you think it is, and then just throw an indicator on there one time. And I mean, once you have the indicator set up, it only takes a couple minutes. Check and see where you're at. See how close you are, because that feel, that's like saying a guy can actually set a ring and pinion backlash by feel. I mean, I've been doing this a long time, and I can't do it by feel. So
here's another quick question for you, Rick, that one of the audience has asked. If you're dealing with a top hat drum, can you use the studs? Can you pull by the studs to get a good reading?
Sure. All you want to do is if you can get opposite, 180 degrees opposite, to make sure you're not cocking the bearing or the assembly. Okay?
Good, thank you.
All right. Of course, if it doesn't meet the preload or the setting is not where you want it to be, then you have to go back and start over again. And there we go again. If you can't get your castellations to line up to get your 1 to 5 thousandths or 1 to 7 thousandths of setting, then what you can do, and what I've done before, is actually change that shim or that backing washer in there. You might have to grind it down. You might have to find a different one, but you can take or change the clearance with that also. All right, now we're going to look at the effects of improper setting, or what can happen. Setting plays a part in these. The first thing we see here is excessive preload or overload. And again, when we were talking about preload, that's inducing a load prior to the application loading. You can see the rapid and deep spalling caused by unusually high stresses. When we say high stresses, we mean on the bearing components themselves. So the roller places stress on the cone and places stress on the cup. Normally for damage at this level, the temperature has been elevated and the surface has been softened due to that elevated temperature. Now, normally you can start annealing a cone at as low as 350 degrees or a bearing component. So if the bearings get over 350 degrees, you can actually start to soften or reduce the temper in the steel. Okay, now the bottom photo there shows the effects of the roller and what you might see riding on that cone. The surface imperfections will affect the roller bodies and start spalling, and that's the removal of chunks or the pieces falling from the bearing. All right, now let's go the other way. The last slide showed you preload or too much loading. This is a condition called misalignment. Another sign of improper adjustment or damage to the hub or spindle. The photo in the upper left and middle right are the same cup, but they're 180 degrees rotated. So what you're looking at in the left one is the exact same cup as the right one. And if you'll notice how the roller path, you can see that by the oil staining there, that it's not riding on the center of the raceway. It's actually riding from the small end to the large end. What this is showing me is that there could be a number of things, but it could be inaccurate machining, which I would assume that any part that we're working on, the original component we took out would have shown this also. But you could not, the cup might not have been seated in the hub correctly, which will cause this misalignment. Okay, it's actually where the cup and cone are not seating together. One is askew of the other. Okay. The bottom photo there shows the effects of the misalignment on a cone, and you'll notice how all the spalling is occurring at the one edge of the raceway. What that's telling me is that the loading to the roller was concentrated on one side or the other.
What are some examples, Rick, that can cause this to become misaligned during installation?
Yeah, during installation, the number one cause I would say is the cup not being seated all the way in the hub, so it actually be cocked in the hub. Okay. Another would be excessive end play, and what I mean is if you have this assembly so loose that the hub will actually like drop or tilt. If you were to play with these, when you put the two bearings in there and adjust them up, you know, you're pulling it in and out. They basically the hub doesn't shake up and down; it just moves a little bit in and out. But if you were to have excessive, and I mean more than 7 thousandths or 10 thousandths, what you're going to notice is that the hub will actually start to rock, and what that is you're misaligning the bearings. It's actually shifting, okay, and not even load distribution all the way across the rollers.
Now, how about if you're installing a new assembly? Is it possible for that clearance to change and need to be reset after it's been run for a bit?
I'm not going to say it's impossible, but if everything was set correctly to begin with, think about this, that the only way you could gain more clearance in there, if you checked the assembly and let's just say you had 3 thousandths of end play, okay? Now let's say you come back, you're checking it again, and you know, I don't know, 6 months, a year later after operation, you notice that there's 5 to maybe 10 thousandths of end play. The only way that is possible is either the cups weren't seated, so you never got the initial setting correctly. There had to be wear somewhere. When I say somewhere, I mean it could have been on the bearing. You will notice that. It could be on that spacer behind the cone. A lot of times there's like a hardened washer between the outer cone and the adjusting nut. And I've also actually seen the adjusting nut wear, you know, which is bad in the fact that it's putting metal shavings into your assembly. That's not good. And the wear is actually increasing the end play, so that's not good either.
Gotcha.
Okay. Okay.
All right.
So, in closing, I'd like to thank you all for attending, and I want to mention that there's installation and damage information at www.timken.com/techtips. It has all the information we covered today plus more. Okay.
Excellent. You can also find the link on that on our Motor Age site as well. Rick, we've got some really great questions for you as well. You ready to take a few questions on?
Sure.
The first one asked goes like this. If you notice that you've had bluing of the rotor due to heat, should you replace the bearings that you mentioned that the 350 degrees Fahrenheit, that I guess that's the upper limit?
Yes. It actually depends on how much heat sink has got to the hub. If it's just the rotor itself, normally those are cooled enough that I have not found where the temperature will creep down to the bearings. I'm not saying that it hasn't increased the temperature of the bearing, but you will notice a change in color to the bearing also. And at 350 degrees, most lubricants do not like 350 degrees. So you will notice that the lubricant is been overheated also. The seals also do not like 350 degrees. So if that hub assembly was hot enough to damage the seal or the lubricant, then absolutely change the bearings.
So I guess something else to be on the lookout for, of course, clean the bearing and visually inspect it for heat damage. I'm sure that you would see probably some thinning to the lubrication.
Absolutely.
That would show up. And, of course, the spindle assembly itself, too. So, yeah, I think if it got that hot, you would see other additional signs to let you know. All right, Dan, thanks for that question. Let's move on to a question here from Patrick. Patrick asks if, excuse me, I think I lost Patrick. I'm so sorry. I don't know how we did that. Well, let's try to go on to Michael's then. Do you have any info on heavy-duty applications and oil bath bearings?
Absolutely. And if you log on to the website that we talked about, www.timkeninfo.com/techtips, there is automotive light duty and heavy duty, and it will cover bearing setting procedures for heavy duty and also lubricants for heavy duty.
All right. Thanks, Michael, for that question. Next one is from Edward Moreland. Edward asks if the vehicle is involved in a collision and the wheel is replaced, but no damage to the suspension and the vehicle is in line past the specs. Could the bearings have sustained some damage that would warrant replacement?
Absolutely. Now, the tough part about this one, or about this question, is can you tell if there's damage? If you tear them apart, sometimes you can see the damage on the raceway. A lot of the newer vehicles use a hub assembly. I have seen bearings returned where it looks like they were Dukes of Hazzard in it. And what I mean by is what it'll actually do is create line spalling or marking in the raceway that is roller space, similar to the corrosion, but it'll actually be dents in the raceway. The same damage will happen as the corrosion. Okay, what you've done is created a high spot or a stress area in the raceway. As those rollers roll over it, it will create damage. So if it was in a major collision, I would automatically replace the bearings.
There you go, Edward. Thanks for that question. Hey, we're back to Patrick's question. Didn't miss him at all there. Patrick asks, many OEMs on the medium truck market want oil lube, not grease-packed bearings, preloaded to 20 foot-pounds as a final adjustment. There is no end play. Do you disagree with this method?
It depends on the bearing style. There is the problem with preloading bearings is it's not measurable. Okay, some of the manufacturers will tell you to torque them up to 10 foot-pounds and 10 to 20 foot-pounds. The only problem is if you err on the preloaded side, if you were to go 1 to 2 thousandths too much of preload, and you don't know it because it's not measurable with a mechanical device, to err on that side, you reduce the life of the bearings. What they're trying to do is by running bearings at zero clearance or preloaded, they get less rotor runout. So what they're trying to do is keep their brake judder or keep their brake performance up by tightening the bearings up. The bearings can be preloaded and work that way just fine, but like I say, if you err on too much preload, then the life curve of the bearing falls off drastically. So the reason that we recommend the end play is it's easier to set and it's easy to measure. Okay, preloaded bearings are tough to measure.
So then I guess, is there always an end play spec listed by the OEM, or is it something that the companies who specialize in making these precision components can actually provide that kind of a spec?
Well, I have seen some vehicles that will give you the spec of preload. Now, here's my concern with them. I know, I believe Ford does it and Toyota does it, just for two, and I believe GM does too on their rear wheels. But what they're trying to do, they'll actually tell you to tighten the assembly, set the bearings, and lock it down, and then they'll request that you either put a fish scale, a string on the wheel studs, and then a fish scale on the string, and as you pull the fish scale, you can measure the rotational torque of the hub. That's a good idea. The problem with that is you also have to include the torque of the bearing, or the torque of the seal, along with the torque of the bearing. You have to calculate that first. So if you did not use the OEM seal, if the seal surface is worn a little bit, your calculations are not going to be right. I mean, the spec that they give you will not necessarily correlate to the same preload that they had at the factory. They have a lot of money invested in the proper tools to set that preload, and that's how they come up with that spec. But what I'm fearful of is unless you go through all that extra procedure, you could err on too tight.
Sure. All right, that answers your question there, Patrick. Next one comes from Mike. His question on boat trailer bearings. How about the bearing buddy? It will totally fill the hub with grease, just lube the outer bearing. However, it will help purge water. Which do you feel is worse, too much grease or salt water?
All right, that's a good question. The bearing buddy, and that's exactly what it's doing, is it's actually forcing grease through the bearing, and as that bearing gets hot, or the hub assembly gets hot, that grease is being forced under pressure. Now, granted, it's not very much pressure, but it has to go somewhere. So what does it do? It goes out the rear seal. It's messy, first of all. It does create excess heat because of too much grease in the hub assembly. Does it keep all the water out of a hub assembly in a boat trailer? I have no proof that it does, but I have no proof either that it doesn't. Do I use them? No. For the small amount of time it takes me to take a hub assembly off and clean it up, grease it properly, put it back on. I mean, you don't even have to replace the bearings most of the time. You just clean them up and put them back together. You can save yourself a lot of headache. We also have a product called AquaSpecs, and what they are is we have them particularly for boat trailer kits. They are a coating on the bearing that helps reduce or virtually eliminate corrosion from water just due to this coating on there. Okay, so it's another form of protection where you don't necessarily have to overfill the bearings with grease.
A great question. Another question from another viewer. Is there a way to determine the useful life of a grease, a generic lifespan? I think I like this question too, because I know a lot of us who use the bearing packer will have grease in there and fill it up, and then it sits. So is there a lifespan for that?
I'll be honest, I'm not a grease expert, but you also have to think the bearing packer is pretty much sealed. So as long as it's not in a high contaminated area or, hot and cold where the moisture is condensing and stuff in there, then I mean, it's a limited amount of grease in there. I use mine, so.
Yeah, so I guess the main thing is keep it sealed and keep it away from areas where other contaminants could get in the grease.
Oh, absolutely. Absolutely.
Along the same lines, this is a question I think that we actually kind of talked a little bit about. We usually use the old cup turned upside down as a pressing tool. Is that an acceptable procedure?
Absolutely. You find it more in the heavy truck industry, but a good way to press the new cup in is I take the old cup, but I'll take it over to the belt sander or something and clearance the OD a little bit. All you got to do is hit it. You're only trying to take a thousandth or two off of there, or you can actually chamfer the edge a little bit. And what you're trying to do is relieve that OD so that it doesn't get stuck in the bore when you're pressing the new bearing in. But yes, that is a very good way, using the old bearing to apply or press in the new bearing. One other thing I want to point out, and I don't know if I said earlier, was definitely do not use the cone or the cup to press the opposite component in. So if you're pressing a cup in, do not put the cone in there and press on the cone assembly. If you think about it, it's tapered. So as you're pressing or applying force axially, the cup is actually trying to spread radially. So instead of driving the cup in, you're spreading the cup out. The potential damage areas, you could actually mark the raceway and cause early premature failure of the bearing. So I just wanted to highlight, do not use the mating component to press the bearings in.
Yeah, good. Here's a good question from Ken. Are the torque specs for setting up the preload, are they same if you're reusing the old bearings as they are when replacing them with new?
No. No. Oh, I'm sorry. The torque specs.
The procedure for setting up the preload, is that the same if the bearings used as whether or whether it's new? We're going to reuse the old bearings.
Yeah, and I think you're referring to like when we're setting up pinions and stuff. The torque will be reduced a little bit, but you can use the same settings that the manufacturer recommends. Okay.
Yeah. And
a used bearing is going to have a little less torque than a new bearing, only because it's what we call run-in. Okay, there's a little bit of wear on there, but you can use the same specs and you will get within the setting range, yes.
Sure, and if you're going to do the brake job and you're reusing the bearings, you're still going to verify it with the end plate.
Exactly.
Yeah.
I thought they were referencing preload, but yeah, the same specs apply to the end plate one too.
Yeah. Okay, I think we have time for one more question before we move on. Are the torque specs the same with? Oh, I thought we just asked this one. I'm sorry. One more from Patrick. In a grease pack application, if the raceway is brown colored, but no evidence of metal damage, is this oil contamination or marking, or evidence of some type of problem, excessive heat or so forth?
Yeah, a lot of times what you'll notice, especially the discoloration, is as long as it's only in the roller contact where the roller is riding on the raceway, it's probably not heat, and it's more what we call oil staining. And that's due to the lubricant that's being used, and that's normally not an issue.
And I think the very last question we'll go with today, and guys, if you have questions, I do appreciate them. We'll see what we can do about addressing those here afterward. What type of grease do you recommend for tapered bearings, particularly in the front end?
Let's go back to it was in my spec earlier here, of course, we have our own performance racing grease and automotive wheel bearing grease that we have, but as long as it meets the NLGI, the GCLB certification, and the NLGI number 2 grade lithium complex, it will work fine in most disc and drum applications.
Well, Rick, I really appreciate your time, and I certainly appreciate Timken partnering with us at Motor Age to present this information to our audience. I'm Pete Meyer, the technical editor for the magazine. If you hang around or if you want to share this with other techs in the shop, we will be archiving this presentation, and you can reach it at the same address where you registered, motorage.com/bearing care. It will also be available at motorage.com in our online community, the AutoPro Workshop, our AutoPro live stream channel, and later on we'll have it even uploaded to YouTube. So it won't be too hard to find it. Once again, Rick, thanks so much for taking the time to join us today. And thanks to all of you who came and attended. Glad you made it. And keep in line for our next one with Timken in February. We'll be doing a live presentation there with our friends at TST. Should be great. See you then.
All right, thank you.